Now we come to the phase shift keying modulation, and this is also a digital modulation. And now taking the same example as in the previous slide, this is the time slot that is assigned to this mobile station in the uplink, and this is the time slot that is being assigned to this mobile station in the downlink. And taking the example of the uplink time slot, if this time slot is being used to send the digital data from the mobile station to the base station, this digital data may be the digitized voice, or this may be the internet data that is being carried from the mobile station to the base station over this time slot or this channel. So we are modulating this data using the binary phase shift keying. So what does that mean? That means that 1 is being represented by a frequency that has the phase of 0 degree, and then 0 is being represented by the same frequency, but it has a phase of 180 degree. So there is a phase change of 180 degree between 1 and 0. So here, whenever you have a transition from 1 to 0 or 0 to 1, you can see that there is a phase change of 180 degrees. So in this case, the 1 is being modulated as a carrier with 0 degree phase, and 0 is being modulated as a carrier with 180 degree phase. And this type, and here this is the case of the binary phase shift keying, because we are modulating ones and zeros individually. And this type of modulation scheme is represented using this diagram. If this is 1, it has this is represented by this symbol that has 0 degree phase, and if this is 0, it is being represented by this symbol that has 180 degree phase. So the mobile station is modulating the ones and zeros, sending it through this time slot, and base station is then demodulating this binary phase shift keying signal. Now in the case of binary phase shift keying, 1 bit was modulated at a time. 1 was being represented by a frequency with 0 degree phase, and 0 was being represented by the same frequency but 180 degree phase. Now in the case of quadrature phase shift keying, basically we are modulating 2 bits at a time. 00 is being represented by a frequency with a phase of 45 degree. 01 is being represented by the same frequency but with the phase of 135 degrees. 10 is being represented by a phase of 225 degrees, and so on. So here we can see that this symbol represents 00 and it has a phase of 45 degree. Similarly, this symbol represents 01 and it has a phase of 135 degree, and this symbol represents 10 and it has a phase of 225 degrees. So in the case of BPSK, as we had only 2 symbols and there was 1 bit per symbol, so we needed only 1 dimension, and this is the cos of omega CT axis, or we can also call it as the I or the in phase axis. So the 2 symbols were along the I axis, while in the case of QPSK, since there are 4 phases, we need 2 dimensions. So this is I dimension and this is called as the Q dimension, which is minus sine of omega CT, and the other name for the Q dimension is the quadrature. So that is why this is called as the quadrature phase shift keying, or QPSK.